In this video, I'm going to discuss congruency with regards to polygons. So let's first make sure we know what a polygon is. A polygon is a two-dimensional shape composed of line segments. So there's a polygon. There's another polygon. You can have more complicated ones with more sides. A stop sign is a polygon. All right. So what I want to address is, what does it mean to say that polygons are congruent? Now, remember that we said that the spirit, the motivation, the desire is to capture what it means to say that the shapes and sizes of two objects are the same. That's what we want congruent to mean. We don't care about the color, we don't care about the position, we don't care about the orientation, the shape and the size. All right. Now, here is one way that you could see if two polygons had the same shape and size. So here's one way to confirm that they were congruent. So suppose that you took a polygon like these. Let me put dots where the line segments come together. Those are referred to as vertices. Okay. Suppose you literally picked up one of the polygons and moved it on top of the other one. Okay. When you move it, if all of the vertices are on top of each other, okay, that means that they are congruent. They have the same shape and size. All right, so you put them on top of each other. Now, they can't just be sort of on top of each other. They have to be right on the points have to be right at the same position. All of them, all the vertices. Okay, so that's one way that we can define congruency, is all the vertices have to be lined up, okay, to be congruent polygons. Now, an equivalent way to check if two polygons are congruent is if all the corresponding line segments and angles are congruent. So we've already made sure that we know what it means for line segments and angles to be congruent. It means that the lengths of the line segments and the measures of the angles are congruent. So let's now use that to define congruent polygons. All right. Polygons are congruent if their corresponding sides and angles are all congruent. So what might be unclear is, what do I mean when I say that by corresponding? Okay, so let's talk about that. So if I have a polygon and I have another one and I think they're congruent, let me make a congruent polygon to one of them that I drew here. Alright, suppose I wanted to confirm that this green polygon, and let's make it blue. Suppose I wanted to confirm that this blue and green polygon were congruent. Well, I have corresponding sides. I'll call them 1, 2, and 3. And how about this one? I'll call 1 prime, 2 prime, and 3 prime. So side 1 corresponds to side 1 prime. Side 2 corresponds to side 2 prime. Side 3 corresponds to side 3 prime. Okay? If those are all of those corresponding sides, if they're congruent, then it has a shot of being congruent. All right. Regarding the angles, let's call the angles angle A, B, and C, and then A prime, B prime, and C prime. Once again, if the corresponding angles are congruent, then it has a chance of being congruent. So the measure of angle A has to be the measure of angle A prime. The measure of angle B has to be the measure of angle B prime. The measure of angle C has to be the measure of angle C prime. Okay, so that's what we mean when we say that they are congruent. Okay, now for a triangle is a polygon with 3 line segments. because we use this idea so much, we actually have an acronym that comes up all the time, which I will show you right now. So people will use the phrase kiptic. That says that congruent parts, or excuse me, corresponding parts of congruent triangles are congruent. So that's basically what I just gave you as the definition of polygons applied to triangles. Okay? The corresponding sides and angles of congruent polygons have to be congruent. So for triangles, of course, the same thing has to be true. And when we use that, we'll say, okay, for this proof, we're using kiptic. All right, so that's just a little cutesy little acronym you'll see that'll come up. Okay, so just keep that in mind. All right, one last comment. You might be wondering why we have to emphasize sides and angles. Certainly, if we have one or both, if all the sides are congruent or all the angles are congruent, isn't that good enough? Well, if the sides are all if the corresponding sides are all congruent, later on we'll learn that that is sufficient. All right. However, that's not the case for just having the angles. Let me show you why on a new whiteboard, and we'll end with this. So here I have a triangle, and let's say that we have 90 degrees, 30 degrees, and 60 degrees. All right. Now let me draw another triangle that has the same exact angles. You see the problem? So this purple triangle can also have 90 degrees, 30 degrees, and 60 degrees. So that's the reason why we can't assume that polygons are congruent just because corresponding angles are the same. We have to have angles and sides